Welcome to this video in which we will consider what control structures are in MATLAB. So control structures are things which are used to direct the flow of the program. Typically these include if-else statements, and these are widely used in any kind of algorithms where there has to be a decision made on the particular value of the output that you obtain from a previous part of the code. So let's say we have a equal to 1, and then you want to print whether a is odd or a is even. So then you write if mod a comma 2 equal to 0, fprintf number is even, \n stands for next line operator, and then you write else fprintf the number is odd, end. So by having an end, it closes the whole if-else block. So this is an example of an if-else block. So you press Ctrl Enter and we have that the number is odd. Alternately, if we have something which depends on three variables, on three states rather, so let's say we have b equal to 1 if mod of b comma 3 equal to 0, so then we will say the number has remainder percentage f \n, and then we will write mod b comma 3, else if mod b comma 3 equal to 1, then we will write the same statement, else this. I mean, you don't need to just print the value, you could do some calculations. You could do maybe, for example, c equal to b square, here you could do d equal to b cubed, or here you could do some e equal to b raised to 4, which is to mean that given the state of b, you will declare some new variable and then proceed with the calculation. Okay, so if I run this, you get a remainder and then you get a new variable of d, because b has a remainder 1. Okay, this is how you have 3 checks. This is how you have 2 checks. This is how you have 3 checks. So note, in this case we made use of else if. So else if is the name of a keyword which sort of carries forward an if-else loop. If an if-else statement has more than one condition, then one must use one if to enter into if-else block, and then keep on using and keep on using else if until you are satisfied. Let's say if you have even more conditions, so you would write something like if something, else if something, else if something, else if something else something, and you would do something like this. Inside each of this you would write some logic statement and then perform whatever you like to do. So let's try to do something useful with this kind of stuff. Let's try to find out the modulo of a number. Not the modulo, but let's try to find out the mod of a number, which is if x is positive, then you return x. If x is negative, then you have to return minus x. This is how it works. In all of the cases, the output has to be positive. So let us define x equal to minus 1. Then you write if sine of x greater than 0, f printf else and we have to output minus x. Okay, so the way to do it is to check whether the sine of x is larger than 0 or less than 0. If it is larger than 0, it means that the number is positive. If it is less than 0, it means that the number is negative. Let's also, we can easily see that. Let's say sine of x is minus 1. Let's say x equal to 5. Sine of x is greater than 1. Okay, this is how you ascertain the sign of a certain number. Now similarly, you can have various conditionals acting on arrays as well. So now we move on from if-else blocks. So one conditional, we have already used a few conditionals, that is greater than 0, equal to 0 and so on. So suppose we declare x equal to 0. Then we can check, suppose we have y equal to 1. We can check if y is equal to x. So the way to do it is, suppose the boolean is stored in C. Then you say C equal to x equal to y. Okay, it's better to put them in a bracket. And now C is 0. C is a logical variable which returns the value 0. It means it is false. You can write d equal to x equal to 0. Then correspondingly d will be logical true. So this is how you do true and false. So this kind of checking, double equal to checking. Alternately, you can have checks for greater than 0, less than 0, less than equal to 0. Okay. So for example, for y, we can check e equal to y greater than 0. And then we can display e. So it's yes, it's true. Alternately, if I make this less than 0, it gives us 0. It means it is false. It is not less than 0. Okay, so let's try to apply this to an array. Let us say x equal to, so let's, in the process of doing this, we'll see how to make an array. We can use the function Linspace. So Linspace means linear space, and the first value is supposed to be the beginning of the array. So look at this. It gives me a pop-up help. says x1 comma x2 comma n. So I must define init val, final val, comma number of values. Okay, so let's say init val equal to -5 -4, final val equal to 4, number of values equal to maybe 10. We take 10 points from -4 to 4 and we store everything inside x. Let's just run this and let me show you what x looks like. So from -4 to +4, it takes 10 values, 10 equidistant values, 10 equidistant linear values. That is why the name Linspace. Alternately, we could also define an array like this: y equal to -4 semicolon 0.1 semicolon 4. It means it will go from -4 up until 4 in steps of 0.1. So let's see what that looks like. Okay, so it has, so look, -4 it starts, then -3.9, -3.8 and so on. It increments them in steps of 0.1. Anyway, so now let's see. Let's clear the screen. Let us store everything in a array called g equal to x greater than 0. Okay, so x looks something like this, and all these values are less than 0, all these values are greater than 0. So let us see what g is. So for -4 it gives me 0, which is false. It is obviously not greater than 0, hence it gives me 0. This is -3, it checks, is this value greater than 0? It is not, hence it gives me a false, and keeps on going up until I reach 0.4444, where it is actually greater than 0, and hence it starts returning 1. So this is how you sort of telescope the operation of this logical to the entire block. So now, if this is the case, let us see how we can plot the mod function. Let us say xm equal to x dot star g greater than 0 plus x dot star, so this should be minus x dot star g less than 0. So let's see what xm is. Oops, so we've gone wrong somewhere because it's just returned. So let's see what x is. Let us see what this value returns. So this gives us all the positive things. Oh sorry, this should not be g greater than 0, this should be actually x less than 0. Okay, there you go, we have successfully converted the negative values into positive values. So what it does is, so let's break this down. Let's focus on this term. Okay, let us first see what x greater than 0 is. It's a logical array in which only the positive values are positive, and this is the x array. So we multiply 0 by this, 0 by this, 0 by this, 0 by this. So we are essentially making all the negative terms with 0 and only multiplying all the positive terms to 1. So essentially we are retaining only the positive values. This means element wise multiplication of x to a logical array in which only the positive values are 1, hence all the negative values go away. Okay, so this gives me this. Now here what I do is this part, it checks which values of x are less than 0, which means these values, and it multiplies them element wise by -1. Okay, so let me quickly print out what these are. Okay, so it multiplies whatever these are with -1 because it is -x into. Okay, clearly this x less than 0 selectively gives me only those elements which are less than 0, and to them I'll element wise multiply -x. So with this I'm able to obtain a modulo function. This is a composite function. Okay, for x greater than 0 the function should give me x, for x less than 0 the function gives me minus x. We will see there are many ways of doing this. There's nothing sacrosanct about this, but in the end it will be nice to plot it. So let's declare a new figure 1, and let's plot. So we should plot x and then function of x and then x comma xn. So this is the original function. So on the x-axis, so the syntax for plotting, I mean ideally we should just plot x comma x, which is to say on the x-axis is x, and on the y-axis we have plotted essentially y equal to x. So it's a straight line with a unit slope. So if I mean one could plot something like this, for example, it's parabola and so on. Okay. But in this case we wanted to just plot x, because it goes from -1 to -4 to +4, and then on the x-axis we again plot x comma xm. So this is one pair of plot, this is the other pair of plot. So xm we have found as a function of x, and it goes and it takes positive values even for negative values of x. This is how it looks. Anyway, plotting will be covered in more details later on. So this is how we can apply simple checks. Okay. Similarly, I mean there can be, I mean in regular practice there are many problems in which this if else is used. Oftentimes it is nested and it is very terse, but it's not so difficult to get the hang of it. So in this particular lecture we stop here, and in the coming lectures we'll look into iterations and how to break iterations and how to make use of if else statements inside iterations. And it is essential to get all these things in a very properly in a very smooth manner to make good progress. I'll see you next time.